Welcome to our Unit 2 review worksheet. Okay, Unit 2 Quiz 2 review worksheet. So let's get started. Question 1, Kelly is completing a proof based on the figure below. She was given that angle AB is congruent to angle EDF and has already proven line AB is congruent to line segment DE. Which pair of corresponding parts and triangle congruency method would not prove triangle ABC is congruent to DEF? So let's mark off what we have. We have angle A is congruent to EDF, and we have line AB is congruent to line DE. Okay, so we have a side and an angle. Side and an angle. First one says AC is congruent to DF, so that's side angle side. That will definitely work to prove it, so we're looking for not proving it. Okay, so let's do the next one. Let's get rid of this, just so I can see clearer. BC is congruent to EF. So this is a side, and an angle, or angle, side, side. And so it's definitely not even side, angle, side, right? And we know that that's a Donkey theorem. It's not going to prove that the triangles are congruent. So your answer is number 2. And you could check the next ones if you want. You know, angle C is congruent to angle F, right? And that would give you angle, side, angle, side. And then you'd have, right, angle CBA is congruent to angle FED, which would give you angle, side, angle. So it's definitely number 2. Let's take a look at the second question. In the diagram of quadrilateral ABCD, right, AB is parallel to CD. Okay, let me see if I can make that parallel sign better. Erase this. Okay, angle ABC is congruent to CDA, and diagonal AC is drawn. Which method can be used to prove triangle ABC is congruent to CDA? Okay, so we have this line is congruent to itself. I'll use the highlighter for it because it's okay. So we have a line and an angle. Let's see. Well, we know it's not going to be 2 because angle side angle is not a theorem we use to prove triangles congruent. So this being parallel lines, we can see that this angle is congruent to this angle. Okay, so we also know, right, so that's angle, side, right? I'm gonna just mark that off. I could already see angle, side, or you could have used this angle congruent to this angle, right? And that would also give you angle, right, angle, side. Okay, I know there's other ways to prove it, but in this particular case, this is what we were looking at, right? Because we had here and here and here. Okay, so to get angle, side, angle, you can prove that, right? But why would you need this to prove that? Okay, you wouldn't, right? You know this is congruent, and this is congruent, this is congruent, and this is congruent, right? So you could have angle, side, angle, not side, angle, side, angle, side, angle. So you definitely couldn't have that, and you wouldn't have side, 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 right? So it's angle, side. Sorry, even I, as an adult, get a little tripped up by all the side angle, side angle, side angle. Like, it's a lot. That's why I kind of double check and triple check work. All right, so in the accompanying diagram of triangle BAT and triangle FLU, angle B is congruent to angle F, and BA is congruent to FL. Okay. Which statement is needed to prove triangle BAT is congruent to FLU? Angle A is congruent to angle L. Well, that would give me angle side angle. That would work. Okay. So, honestly, that's really enough, but I will check. AT is congruent to LU. That's an angle side side, so that doesn't work. Angle A is congruent to angle U. That's not true. They're not corresponding. And then the other one tells me about parallel lines, which has nothing to do with anything I'm doing. Okay, so it's number 1. Question 4. In the diagram below, right, line segment AKS and segment NKC, segment AN and SC are drawn such that segment AN is congruent to SC. Which additional statement is sufficient to prove triangle KAN is congruent to triangle KSC by angle side? So, AS and NC bisect each other. So AS and NC bisect each other means that this side is going to be congruent to this side, and this side is going to be congruent to this side. Okay, that looks like it's side, 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 not angle, angle side. I get that you can prove the triangle's congruent, but that's not what they're looking for. They're looking for you to use angle, angle side. So, put that back there. Okay. K is the midpoint of NC. While K is the midpoint of NC, gives us a side here. Okay, that's not really going to help us. We have 2 sides. We need 2 angles. Okay, and we do know, just so you know, that these are vertical angles. So we know that this angle, AKN, is congruent to CKB. Okay, AKN is actually congruent. Sorry, let me rephrase that to SKC. Okay, now, AS is perpendicular to CN. That doesn't really help us with more than one angle, because it's telling us this is perpendicular to this and they're congruent, but we know they're congruent, so that only gives us a piece of information we already have. Okay, so let's take a look at AN is parallel to CS, and by that we can use this as a transversal, and so we could use an angle here if we wanted to, and that would be angle, right, angle, angle side. Okay, or we could have used the angle here, right, by, I'm just going to mark it off, right, and then we'd have angle, angle side again, right, because when 2 parallel lines are cut by a transversal, their alternate interior angles are congruent. Okay, so let's take a look at number 5. I'm kind of just rushing through it. My Mac battery is dying. Okay, so which condition does not prove the 2 triangles congruent? This one is really easy. So we know this works. We know this is the donkey theorem, right? ASS, SSA, anything that spells a bad word is not a congruency theorem. So let's move on to number 6. Okay, which statement could be used to prove triangle ABC and A prime, triangle A prime, B prime, C prime are congruent? Draw the triangles and label them. So I'm actually going to I'm going to use 2 triangles. I just need any triangles, and I'm going to label space is what I need here. Now I'm doing this problem, but I needed space. And I'm going to label A, B, C. A prime. B prime. C prime. Okay, these are probably not what the triangles would look like, but I need something to be able to work with. So AB is congruent to A prime, B prime. BC is congruent to B prime, C prime, and angle A is congruent to angle A prime. That would be angle side side. That does not work. So let me go to the next one. AB is congruent to A prime, B prime. Angle A is congruent to angle A prime. And angle C is congruent to angle C prime. Okay, and that would give me angle, angle, side, and I just want to let me just try to make that clearer. Okay, so I'm going to use a different color. So if AB is congruent to A prime, B prime, we have angle A is congruent to angle A prime, and angle C is congruent to angle C prime. Now you could try the other ones, but this is, the third one is angle, 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 so we don't use that one. And the other one is angle side to side, and we're not going to use that one, so it's definitely number 2. Okay, I recommend drawing things, even if they're not to scale, just so you can have an idea and have a visual of how the letters are working and the corresponding parts are working, okay, with the congruency theorems. So number 7, in the diagram below, AC and BD intersect at E. So not bisect, intersect. So we know about these angles because they form vertical angles, but we don't know anything else about congruency in the side lengths because they intersect, they don't bisect. Which information is always sufficient to prove triangle ABC is congruent to triangle CDE? So AB is parallel to CD, okay? So that would help us proving angles, but we already have, right, an angle, and we don't have any other information about sides. And we know we can't, just with 3 angles, isn't going to help us prove congruency. So we have AB for number 2 is congruent to CD, and BE is congruent to DE. Okay, well that's angle side side, that's not helping us. And I actually want to redraw this better. Okay, E is the midpoint of AC. Well, that gives me a angle side, didn't help us completely. Okay, I need 3 pieces of information. BD and AC bisect. Well, that's perfect. So now I have an angle, side angle, and a side angle, side. So your answer is number 4. Okay. In which of the following could you efficiently prove triangle A is congruent to triangle 2 using HL theorem? So these are all right triangles, okay? HL is a leg and a hypotenuse. So I'm looking to find legs and hypotenuse, right, congruent. So this has no hypotenuse congruent, okay? Even if they are, it doesn't matter because they're not showing me it. So I need the information they are given to show it. This has no hypotenuse congruent. Now this one has a hypotenuse congruent and you don't see the leg, but we know reflexive property. Okay, so this leg is congruent to itself. So we have a leg and a hypotenuse. The leg, hypotenuse, right triangle. So your answer is E3 only. Okay, number 9. I know I'm going through it fast. My battery is dying, so I just would like to get up to 10. And then I'm going to make it, well, actually it'll all be on my video, but I want to get up to 10. Line segment EA is the perpendicular bisector of ZT, and ZE and T, this should be TE or ET is drawn. I like ET, right? ZE and TE are drawn. Which conclusion cannot be proven? Okay, so we have this is a perpendicular bisector, perpendicular, and we have a side. Okay, EA bisects ZET. Well, once you prove the triangle's congruent, you could definitely prove that this is a bisector, and perpendicular bisector theorem. I'm not even going to get into that right now. Okay, triangle EZT is equilateral. Well, even if we prove the triangles are congruent, and we could prove that this side is congruent to this side, right? We don't know if all three of them are congruent, so I'm thinking it's probably this one. Okay, EA is the median of triangle EZT. Well, the median, you have a line that's hitting the midpoint from the vertex. That's definite. Okay, angle Z is congruent to angle T. Well, once you prove the triangle is congruent, you could definitely prove the corresponding parts are congruent. So I am going to stick with 2 being the answer. Triangle EZT is equilateral. Let's take a look at number 10. Okay, in parallelogram ABCD shown below, diagonals AC and BD intersect at E. Which statement must be true? So it doesn't tell us they bisect, it tells us they intersect. So we know that the angles are vertical angles, and we know vertical angles are congruent, and also they form a linear pair. So it's depends on which perspective you're looking at, which way you're looking at it. So let's take a look. AC is congruent to DB. We do not know that. There's no evidence of that. Okay, angle ABD is congruent to angle angle CBD. Let me go back. ABD is congruent to CBD. Alternate interior angles. These are not alternate interior angles or corresponding angles, so that's not true. Okay, triangle AED is congruent to triangle CEB. Well, we know that this is congruent to this for alternate interior angles, and we know this angle is congruent to this angle because of alternate interior angles. And because it's a parallelogram, we also know that this side is congruent to this side. So we have angle, side, angle here. So that is going to be your answer. Okay, there's a lot of information given, just thrown at you. Just to go over the last one, I'm just going to put my angles here. God, it's so hard to draw with the mouse. Right. I actually just want to do a color here and a color here to show that these two are congruent, and then these two are congruent. I feel like it's hard to see. Okay, so triangle DCE, so DCE, okay, is congruent to BCE. Well, there's no reason to believe that. Okay, so, but we do have reason. We have, when we're doing this triangle, I'm going to use yellow to do it. This triangle and this triangle, right? We know we have alternate interior angles. Here and here, and we know we have alternate interior angles here and here. And we know this side is congruent to this side because it's a parallelogram. Okay, and opposite sides are congruent. All right, given, right? ABCD is a parallelogram. AB is congruent to CD, AD is congruent to CB. Label all congruent parts using tick marks for sides and arcs for angles. Okay, so AB is congruent to CD. These are tick marks. And then we have AD is congruent to CB. Okay, and it's a parallelogram, so I know this angle is congruent to this angle, and this angle is congruent to this angle because of alternate interior angles. And in a parallelogram, I also know opposite sides are congruent. I mean, opposite angles are congruent. So, I kind of have a lot of information here. So I'm making write all congruent statements for the sides and angles. So I'll do my sides first, right? Well, let me see. Oopsie. A, B, they already gave us this. Let me see if I can find a congruency symbol in Microsoft Word. Struggling here, struggling. Alright, there's one right here. I'm just going to copy and paste it. Make my life easier. AB is congruent to, they gave me this already, so. Oh, these are corresponding sides. These are angles. Label all the congruent, write all the congruent statements for sides and angles, while corresponding sides are what are congruent. So, congruent to CD. And AD is congruent to CB. And AC is congruent to AC. And okay. And I'm just going to take these all off bold. Okay. Those are our congruent sides. And now we have to do angles. So the easiest one we have is angle B is congruent to angle D, because I could label those with just one letter. The other ones, because of the way they're cut up, they have to be labeled with 3 letters. So I'm going to do angle ACB is congruent to angle CAD. Right? This here is congruent to this here. Then I'm going to go to my next angle, and I have angle AD. This should be C. That was ACB CAD. Okay, so I did. Just going to erase some stuff so I can see what I did. Okay, so now I have angle CAB, which is angle CAB, congruent to angle ACD. Okay, so I have 3 angles that are congruent. Okay. Okay, so you should have 3 sides and 3 angles, because we're talking about corresponding sides and corresponding angles. Okay, list all congruent theorems. Oof, that's a lot. Okay, so that prove. So let's start off with, we know this is congruent to this, and we know this line is congruent to this line, and we know this is congruent to itself. So we know for sure side, side, side congruency theorem. And we know that this angle is congruent to this angle because opposite angles in parallelograms are congruent. So we know side, angle, side. Not just because I want to say it, but because we have a side, an angle, and a side. Okay. I'm going to erase some of this and just leave my given stuff. Well, this was given. So we have this side is equal to this side. That doesn't help us with this, but it does with side, angle, side. We could do side, angle, side here. Okay, we can do this side congruent to this, and we have an angle, angle, side. Okay. And we could do an angle, even with this one, we have angle, angle, side, or we have angle, angle, side. There's so many different ways to do angle, angle, side with the information we have here. And then we also have angle, side, angle, angle, side, angle. Okay. All right here can be done. Okay. It's just a matter of what you're showing as your statement and your reasons to tell which one you are going to use. Okay. Looking at number 2, is triangle ABD congruent to CBD by HL? If so, state the leg that allows us to use HL, then prove triangle ABD is congruent to triangle CBD using HL. So I see that we have a right angle here that makes this a right triangle. The hypotenuses are congruent, and I know this leg is congruent to itself. So yeah, HL can be used. So triangle blah 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 is congruent by HL. Right? Hypotenuse leg congruency theorem. Okay, if so, state which leg allows us. Well, BD is the leg that allows us to use HL, right? Because BD is congruent to itself. Okay, so now we have to prove it. Okay, so we are given, right, by the marks here, that AD, just want this thingy, is congruent to CD. Okay, and well, line segment ABD is congruent to line segment CD. I'm not going to write the line segment pieces because it's just too hard. And we also know that angle BA, right, and angle DBC are right angles. Okay, this is given. Okay, so we know, right, we have a hypotenuse and we have a right triangle, so I'm just going to be saying this here are right triangles. And I'm going to use this triangle symbol. I'm just going to actually ABD and CBD. I'm actually going to change this because I noticed that I didn't have it in the same order that the triangle was written in. Is it the same angle? Yeah, but I want it to be in the same order. So I'm showing all of my corresponding parts. Okay, and that's just how we are able to say they are congruent. Okay, they're right triangles. Triangles with right angles are right triangles. Okay, so we have a hypotenuse. We know it's a right triangle, and we're going to say BD is congruent to BD, and this is reflexive property. Okay, and now we can say that triangle ABD is congruent to triangle CBD, right? And this is because of hypotenuse. Feel like leg congruency theorem. Okay, so that's one proof down. Let's look at another one. Given BD is the median to AC, okay, and AB is congruent to BC, so this means the median of AC, that means that this is the midpoint, and AB is congruent to BC, and I need to prove that angle CBD is congruent to ABD, so that this angle and this angle is congruent. Okay, so let me get started with my given. BD is the median to AC, and AB is congruent. BC, and this is given. Now we have, right, we know AD is congruent to CD because, right, a median is a segment that goes from a vertex to the midpoint of the line opposite to it. So a median is a segment that goes from, right, a vertex to the midpoint of the line or line segment opposite to it, right? Opposite to the vertex. I'm just going to put this. Okay, so that's our median. That gives us that this is congruent to this. And there's definitely a few different ways to prove this, okay? So you could use, I'm just going to use the simplest one right here. This side is congruent to itself, because why am I going to make things complicated? I know it's an isosceles triangle because of the two congruent sides. I know I could work with angles after that, but I'm going to make it the simplest because working with reflexive properties is a lot easier, right? You're more than welcome to prove about the isosceles triangle to prove the triangle is congruent. Okay, BD is congruent to BD by reflexive property. And so now, before we can prove these angles congruent, right, we need to prove that the triangles are congruent. Okay, maybe I should have said that even earlier, right? Because we know that the corresponding parts of the triangles, but we need to prove that the triangles are congruent first. So now, and I'm going to steal this and change the letters to CBD, right? Because we're working with triangle CBD, and we're working with triangle ABD, which is actually really similar. All right, so we have these two triangles that are congruent by side, 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 side congruency theorem. Okay, and now I can say that this angle, and I'm just using this because I don't want to go into symbols in Microsoft Word, is congruent to angle ABD Okay, and this is because corresponding parts of congruent triangles are congruent. Okay, and you might want to say, but I would write it out, corresponding parts, congruent triangles are congruent. Okay, so let's take a look at the next two problems. This should actually say 5. Okay, so given, and let me just move this down so it's all in the same, move it down so it's easier to make sure it stays. Okay, given XZ bisects angle WXY. Okay, so this is always getting you guys, when you see bisects, you have to make sure is it saying an angle or a line. Okay, you can't just make it up. Okay, so we have WXY is congruent over here to YXZ. Wait, WXZ is congruent to YXZ because they're being cut by XZ. And we are also told that angle XWZ is congruent to XYZ. All right, now we're talking. And this I know is congruent to itself. So I already see angle, angle, side. Okay, I don't see angle, side, angle. And I don't see side, angle, side. Trust me, it's not always going to be side, angle, side. Okay? It can be, but it's not always going to be. Please just don't just go to that based on like a guess. Okay? So first we're going to put in our given information. copy and paste so that I don't have to write it. And you could write the numbers there as well. I didn't do it on the last ones because to me it's like they were going together anyway. Okay, and from there we said angle, right, WXZ, right, is congruent to angle YXZ, and the reason for that is an angle bisector divides an angle into two congruent angles or parts. Okay, it doesn't matter. So we have the angle given, this angle now that we know, and we know XZ is congruent to XZ because that is reflexive property. And now we can show that this triangle XWZ, right, is congruent to XYZ because of angle side congruency theorem. Okay, now the last one, number 5. Okay, we are given here that KJ is parallel to ML. So this line is parallel to this line, this whole line. Okay, and we are given that KJ is congruent to ML. We need to prove that KJL, right, the triangle KJL is congruent to LMK. Okay, well, we also know that this is congruent to itself, and because these lines are parallel, let's just extend this transversal. Oops, I'm going to extend it with this highlighter because it's much easier to draw with. Okay, we're extending that transversal, and I'm going to change my color to see it easier. Because it's a transversal, I know that I can say this angle is congruent to this angle because alternate interior angles are congruent. Okay, so easy peasy. Angle side angle side. Okay, so we have, if we can, just copy and paste this. And that's given. We know that KL is congruent to KL. Okay, and that's reflexive property. And we also know that angle JKL, I like using the symbols whenever I can. JKL is congruent to MLK, okay, and parallel cut by a transversal triangle have alternate interior. Hey Siri, thank you. Alternate interior angles. Okay, now that we have that, we have a side that was given, an angle from the parallel lines, and a side from reflexive property. Okay, so this is proven the triangle is congruent by the side, angle, side theorem, congruency theorem. Okay, so they're not that hard. You just have to take them step by step. I know they could be confusing because it's given a lot of information, but just think about when you write an essay and you have the research you've gotten, right? You break down what you need to break down, and you don't say it all in one sentence, and you don't say things that you don't have evidence for, right? It's like text-dependent evidence. That's what you're using. They have given here, right? They have these givens. Those are your text evidence, okay? And you are writing statements based on them. Okay. So what I would like to do, if I can, I can't, because it was hard to, okay. I feel like this should, of course, have the line segment signs, but it's too much. Okay. All right. So that's it. I hope you do well. Let me know if you have any questions. Thank you.